Hello everyone, welcome back to System Shogun. Based on my own experience and based on what I've seen throughout the years, 90% or so of the applications use the following architecture and system design. In this video, the idea is to just go over it and maybe learn something more about it. So first, let's see here. We have a basic monolithic system where we have clients. This could be any desktop application or a browser or a smartphone application, so a native application. And then you go over the internet, you hit a web server, and there's a database behind it, and basically that's it. In here you have some monolithic application, so here's where you have your code base, and your code base is working with the database. Like 90% of the applications are using this design. And let's be honest, this works. But what are the flaws here? You don't have a protection from attacks. It's the first and maybe the most critical one. Because in this design, your web server is directly accessible over the internet. And there is no protection. Any attacker can do any denial of service attack or any other attack out there. Other thing that this system design lacks is that there is no load balancing. For example, what happens if your server goes down? And it will go down at some point, trust me. Well, what will happen is your application is down and your clients will get angry. Can you imagine if this is a bank, financial institution, or something like a medical service provider? This is unacceptable. And I mean, it's okay based on the type of application you are building. If it's a basic web app and it's not something critical, this is okay. You can live with that. I mean, even if your server is down, who cares? It's not something critical. Your application is not critical, and basically no one depends on it to be up all the time. Let's see what we have here. So here we are going to the cloud. And to fix some of the issues that I mentioned, we'll add something called a reverse proxy. What is a reverse proxy? Well, it's a service and it's a server, your public entry point. So no longer your clients are going to your application server directly. They're going to the reverse proxy. And the reverse proxy gives you security, load balancing, TLS, SSL termination, and caching. Which is important because otherwise anyone can find your server's IP address and anyone can target them. Any attacker can do damage. And usually the reverse proxy services, they come with some security built in. They can mitigate many of these threats for you. Another improvement that we added is now we have multiple servers. Why? Because of the issue that I said earlier, what happens if your server goes down? Well, in this case, since we have a reverse proxy and the reverse proxy has load balancing feature built in, so if server A goes down, no problem. The traffic will go to server B and the application will continue to work. So we have a higher availability here. Okay, that's monolithic system in the cloud with some added benefits. If you are using the cloud, this should be the minimum that you strive for. You need to have some reverse proxy that protects you from attacks, that does load balancing, and the other features like caching or TLS termination. Okay, let's see the next slide here. Usually, the reverse proxy isn't a single server, as you might guess, because otherwise it becomes your single point of failure. So again, we have this thing of what happens if our reverse proxy goes down. Well, we have the same issue like we had before, but usually the reverse proxy isn't a single server, but rather multiple servers. Okay, and now let's zoom all the way out and look at the full picture. So here is what actually happens when you or your clients type your domain, for example, myapp.com. And usually people don't know this, but it's pretty important. So let's see what happens when a client hits myapp.com. Well, the first thing that happens is something called DNS lookup. Basically, we're asking this DNS, which is a group of servers. We're asking what is the IP address of myapp.com, and through some sophisticated process, it figures out the IP address that is the place where our request needs to go. So the DNS returns the IP address, and then we continue with this IP address as a destination to our request. And I should mention this, like I said here. The DNS queries also go through the public internet. This is where things get interesting, and this is what most people don't know. So, the public internet, what is it? Well, the public internet is a group of routers all over the world. These routers are grouped in these autonomous systems or networks. These routers use a protocol called Border Gateway Protocol, which basically is the global IP routing mechanism, and through that, our request goes through multiple routers to the closest edge location for this particular IP. For example, I am from Bulgaria and I type google.com, then first the DNS will return an IP address which is not a single machine. This is a virtual IP address, and this is using something called Anycast, which is basically a way for many locations to broadcast the same IP address, saying that, hey, I can handle this IP address routing. Let's say in this case, it figures out that the closest place that can handle my request is Frankfurt. So the request goes to Frankfurt's cloud provider edge location, and this edge location then starts handling this request. And this cloud provider edge location is owned by the cloud provider, either AWS, Google Cloud, Azure, you name it. If I'm from Bulgaria, it will try to find an edge location that is closest to me. In this case, for example, it will be Germany. And this is why users like me in Europe hit an European edge cloud provider, and users in the US hit a US edge cloud provider, even though they all use the same domain and the same IP address, which is not a single place. And only after the request reaches the cloud provider edge does the cloud take over with TLS termination, security, traffic load balancing, and everything else. And that's, in a nutshell, how this works. And like I said, it's a bit simplified, but if you get this, you already know more than 99% of the developers and architects out there, I'm sure. That's it. I really want this video to be short, simple, sweet, and I really hope that you learned something. I'll see you in the next video.